The last point of extensibility I want to take a look at is building a custom module. So we've talked about building custom applications, building custom handlers. The last thing you might want to do is build a custom module. And to preface this, let me just make sure everyone's clear. Custom modules are essentially equivalent to custom applications or global ASIX files. So you can do everything in a global ASIX file that you can do in a module, but we'll talk about why you might want to do something in a module versus global ASIX in a few minutes. So just keep that in mind, that in terms of functionality and types of things you might do, modules are essentially equivalent to top-level application objects. So how do these work? So conceptually, modules are similar to ISAPI filters in IIS, if you come from that world. They give you the opportunity to intercept all of these application level events, and you can deploy them into a site just by dropping them in the config file. And they have the interface is HttP module that you'll use to build them. And it's a very simple interface. It just gives you one method, basically, the init method. And init gives you a reference to, what else? The application object. So it's going to give you a reference to the application object, and what you'll do is typically wire up event handlers for any event that you want to tap into in the application. And as we'll see, quite a few pieces of ASP.NET are actually built using modules, and we'll take a look at all the various modules that are installed by default in your machine in a few moments. Let's start just by writing a custom module though. So what I'm going to do is go back to the global ASX file that we wrote earlier, and I'm going to take this functionality, the begin request and end request, and re-implement it as a module instead of an application class, so you can sort of see the difference between the two. So let's begin by adding a new class definition, just like we did for the custom handler. And let's call this the timer module, because it's going to track page timing. And let's put this in a namespace. And let's take out the constructor, which I'm not going to use, and begin by implementing HttpContext module. And again, we just have that pair of methods. Dispose I'm not going to take advantage of here. And what I'm going to do in init, it's funny, the wizard always names this parameter incorrectly, so I like to change that. Init is, we're going to wire up event handlers. So I'm going to grab the application, and I'm going to wire up the begin and end request events, just using standard delegate subscriptions here. And let's do the same thing for end request. Good. Okay, and then let's bring over our implementation from global ASIX. So inside of begin request, we're going to capture the current time right here. Now in this case, I actually am going to be overlapping with global ASIX, so I do want to make sure the string is distinct. So let's call this the timer module start time, and end request is going to be the same thing pretty much as we had here. All right, in fact, let me change the order so it's a little more intuitive to look at here. So begin request is above end request. Okay, good. So, and let's change this string too to make sure they match. Okay, that should be good. Now you'll notice the context is not working for me here. I can't refer to the context. That's because it's not part of the module class, obviously. I'm just building a class that implements HTTP module. So what I need to do is actually get access to the application somehow. And it turns out the application is going to be the object coming in as the sender of this event, because it's the object that issues the event. So what you can do is just say HTTP application app is equal to sender as an HTTP application. And then you can say app.context. And we'll do the same thing down below here, so we can easily reference the application anytime we need to talk to the context or the response. So that's pretty much the only thing we'll have to change in our implementation. Otherwise, it should all work fine. Okay, so there we go. Now I have the timer module in place. Notice my global ASX is still commented out, so that is not going to be contributing to the response at all. So it should be just in the timer. So that's a valid module now. Let's just compile it and make sure we don't have any errors. Okay, compile succeeded. And the last thing I need to do is actually configure it. So you're going to go into your configuration file, locate the HTTP modules section, and we're going to add another module entry here. So add name equals timer module, and then you just specify the type, which in our case is ps.timer module. Okay, and again, if it were an assembly, if it weren't part of this application, this web application under app code, I would have to specify comma the assembly name, and if it were deployed in the GAC, you'd have to do the full version culture and public key token, just like we have up above there. Okay, so that should be installed. Let's make sure that the class name was right. Timer module PS, timer module PS, looks good. So that should be applied now. Let's go ahead and try running our default page. And notice we're getting the output at the bottom, which is good, just like we did before with application, but now it's being done through the module instead of the global ASAX file. Good. And just to show you that this, you don't have to do anything special to configure modules in IIS. They work the same way. If I go browse the same page in my IIS installation, notice that I'm also getting the output of the module down below. So you don't have to configure anything differently because you're not dealing with endpoints here. You're dealing with classes inside of the pipeline that are simply tapping into various events.